A four-engine transport is sitting on a runway with all four propellers still turning, its rear door open, and a man is walking toward it on purpose. Nothing about this is an emergency. He is walking into the loudest few square meters on that airfield, and he is doing it on a schedule with a clock running somewhere behind him that everyone here can quote. In front of him, the aircraft is not parked. Parked means shut down, chocked, cooling. This one is still alive, still burning fuel, still able to move on its own. Every second it sits there is fuel it will not get back. That is the entire reason for what is about to happen next to it. The load in the back has to come out. Normally that means shutting the engines down first, and shutting down is not a switch on a panel. It is a process with a length, and everyone standing on that concrete knows roughly what that length is. Shut down, and you have bought yourself a restart. Checks, power, spin-up, systems, clearance to move again. On the clock that matters, the restart can cost more than the offload. So the decision goes the other way. The engines stay running, the ramp comes down, and the work happens underneath machinery turning at full speed. There is a name for it. Engine running onload and offload. ERO. Cargo goes in or comes out, while the aircraft never stops running. There is a version for fuel called hot pit refueling, a fuel hose connected to an aircraft that is still burning fuel through its own engines while you do it, and a version for both fuel and weapons at once. An integrated combat turn where an aircraft lands, is refueled, is rearmed, and leaves again without ever going quiet. All three exist for the same reason. On the ground, an aircraft is not doing its job. It is expensive, it is stationary, and it is easy to find. The number everybody here is protecting is ground time. Not fuel, not manpower, not paperwork, minutes. A conventional turn, land, shut down, refuel, reload, restart, is measured in hours. A hot turn is measured in single digits of minutes, and that gap is the whole point. That difference is what an entire procedure was built to buy. And every one of those minutes is paid for with a rule that removes a choice from somebody. Subscribe. Start with cargo, because that is where the rules are easiest to see. A transport lands, rolls out, and turns onto a strip of concrete with its engine still up. Nobody moves toward it yet. The aircraft is still deciding where it will stop, and where it stops decides where every person on that concrete is allowed to stand. One person is already out in front of it. He is standing where the pilots can see him, arms up, and for the next 2 minutes, he is the only one talking. He is not talking with his voice. Next to 4 turning propellers, a voice is worth nothing, and a radio can fail without anyone noticing that it has failed. So the language is hands. Arms crossed above the head means stop. Arms out and beckoning means come forward. The signals are fixed, published, and identical across the force. That matters more than it sounds. The person marshalling and the crew flying may have never met. Maybe from different units, different services, different countries. The vocabulary of hand signals is the only thing the two of them are guaranteed to share. When the aircraft finally stops, it is still not safe. The propellers are turning, and each one has an arc around it that everybody treats as if it were solid metal. That arc is not painted on the ground. It exists in the briefing, in the training, and in the head of every person standing near it. The approach is from behind, always from behind, along a lane that was briefed before the aircraft landed, never around the nose, never under a wing to save yourself 10 steps. The ramp at the back comes down and becomes both a door and a road. Everything that leaves the aircraft leaves through it, and nothing at all goes around it. Inside, the floor is rollers and locks. Pallets sit on rails held by latches that were set for flight and are now released in a fixed order, back to front. Release them in the wrong order and nothing dramatic happens. The load simply stops moving, somebody has to reset it, and the clock this was all built around keeps running. There is a version where the aircraft unloads itself. It rolls forward under power, and the pallets stay behind on the concrete where it used to be. That is a combat offload. No forklift, no loader, no ground equipment at all. The load slides out on its own rollers, and the aircraft simply drives away from it. It exists for airfields that have nothing. No trucks, no cranes, no cargo yard, no people waiting, just a surface, an aircraft, and the crew already on board it. Where a loader is available, it becomes the other half of the choreography. It comes in from behind, squares up to the ramp, and stops exactly where a person tells it to stop. That person is walking. Vehicles near a running aircraft do not move on their own judgment. Someone on foot owns their movement and stays visible the whole time. Under all that noise, everything is already timed. The load team knew the pallet count before they stepped out of the truck. The order of moves was decided before the aircraft landed, and each person already knows which pallet is theirs and where they stand while it moves. That is the part people miss watching it. The speed on the ramp is not improvisation. It is rehearsal. The same short set of moves, repeated until it takes minutes instead of an hour. Now fuel, same idea, different physics, and a much shorter list of things anyone is permitted to do. A hot pit is a fixed point on the airfield. A fuel line runs to it underground and ends in a hose and a small crew whose entire job is this one connection. The aircraft taxis in and stops on painted marks. It does not shut down. The pilot stays in the seat, hands where they can be seen, and the aircraft stays able to move. What happens next is fuel moving through a hose a few meters from running engines. Everything that follows exists because of two things: static electricity and vapor. The first thing connected is not fuel. It is a bonding cable which puts the aircraft, the hose, and the fuel source at the same electrical potential before anything flows. Without it, two pieces of metal at slightly different potentials can produce a spark at the exact moment fuel vapor is in the air. With it, there is no difference left to discharge. Then the nozzle goes on, and the crew settles into a posture that looks strange from outside. Hands on the hose, eyes on the aircraft, nobody looking at anything else. Personal electronics do not come into that area. Not mainly because someone might be distracted, but because the device itself is an electrical source nobody accounted for. The same goes for anything loose. A pen, a badge, a cap near an intake is not litter. It is an object about to be pulled into a machine at very high speed. That is the reason for the pocket check everybody does before walking out. Zipped, emptied, and confirmed by a second person who has to say it out loud. While fuel is flowing, the aircraft does nothing else. Systems are set, weapons are safe, and the number of people inside the area is kept down to the smallest number that still gets the job done, because every extra person is one more thing for the crew to keep track of. When the tanks are full, the nozzle comes off before the bonding cable does. Fuel first, bond last. The exact reverse of the order in which they went on. Then hands again. A signal from the pit crew, an acknowledgement from the cockpit, and the aircraft rolls out of a refuel that took less time than this explanation of it. Now put weapons inside that same window, and you have the hardest version of all of this, an integrated combat turn. Normally, fueling and arming are kept apart on purpose. Two hazards, two crews, two separate windows of time, so that a problem in one of them never meets the other. An integrated combat turn puts them together deliberately. Fuel going in on one side, munitions going on under the wing, engines running, everyone working within a few meters of each other. That is not a shortcut anybody takes casually. It is a certified procedure with a named list of who may be inside the area and exactly what each of them is doing there. The weapons crew works from a checklist that is read aloud and answered aloud. Nobody works from memory here, no matter how many hundreds of times they have done it. The fuel crew works from theirs. The crew chief owns the aircraft and the ground around it, and nothing happens near it without being acknowledged by that one person. And the whole thing is measured, because the point of it is a number. The aircraft leaves fueled and armed in a fraction of the time a normal turnaround would have taken. Move all of this off a paved airfield and it gets tighter still. Take fuel to a place that has no fuel, a forward arming and refueling point. AFARP is a transport that lands somewhere austere, keeps its engines running, and becomes the fuel station itself while other aircraft come to it and go again. Hoses come off the ramp of a running aircraft and are dragged out by hand across dirt or matting to whatever is waiting to be fed. The receiving aircraft does not shut down either. A helicopter sits there with its rotors turning while a hose is walked out to it and connected by somebody on foot. Everyone on that ground is working inside 2 sets of running machinery at once, in a place with no lighting, no fire station, no tower, and no infrastructure of any kind waiting to help them if something needs to stop. Which is exactly why the procedure is heaviest where the facilities are lightest. The rules are the only infrastructure that arrived with them. Then the hoses come back in, the ramp comes up, and the aircraft that was a fuel station for 20 minutes goes back to being an aircraft. Across all 4 of these, ERO, hot pit, combat turn, FARP, the same short list of rules keeps showing up, and it is worth saying plainly. Rule 1, approach is granted, never assumed. Nobody walks up to a running aircraft because they have business with it. They walk up when they have been seen and acknowledged. Rule 2, the path is fixed. From behind along the briefed lane, outside the arcs, and the same path every single time, so the crew always knows where to look for you. Rule 3, nothing loose comes with you. Pockets checked, headgear considered, tools counted before the work and counted again after it. Tools especially. A tool left inside a panel is not lost property. It is an unaccounted object inside a machine that is about to fly. Rule 4, hands over voices. Signals are visible, standardized, and cannot be misheard, which is a property no radio and no shouted word has ever had. Rule 5, and the one that surprises people, anyone can stop it. Any person in that area, regardless of rank or trade, can call everything to a halt. That authority is designed in, not offered as a courtesy. The person best placed to see a problem is usually the one standing closest to it and lowest on the list. None of those rules are unusual on their own. What makes them heavy is that they are applied around machinery that nobody switched off first. And then there is the question of who is allowed to be out there at all, because none of this work is open to whoever happens to be available that day. Each of these procedures carries its own certification. People are trained on it, evaluated on it while somebody watches and writes, and then signed off for that specific task, on that specific type of aircraft, in that specific kind of operation. The certification does not last forever. It expires, it has to be renewed, and it can be limited to one type of aircraft or one kind of operation. That is why a unit rehearses a hot pit long before it needs one, and why an exercise will run the same turn over and over on an afternoon when nothing is at stake. The repetition is the product. A procedure that only works when everyone is fresh, briefed, and calm is a procedure that does not actually work, which brings up the condition nobody gets to choose. All of this happens at night as often as it happens in daylight. In the dark, the same steps are done with less light than a parking lot, sometimes with the field lighting deliberately kept down, sometimes with no white light at all. The hand signals survive it because they can be given with lit wands. The paths survive it because they were walked and memorized in daylight first. Weather does the same thing. Rain, wind, and cold do not change the sequence at all. They change how long each step takes, and the crew is expected to know that number in advance, which is the honest answer to why the rules are as rigid as they are. They are not written for the good day, with daylight and a dry ramp and a crew that slept. They are written for the version of the day where nothing at all is convenient. Go back to the man walking toward the running transport. The distance he covers is maybe 40 meters of open concrete. In those 40 meters, he has been acknowledged by a marshaller, has stayed outside 2 propeller arcs, has come in from the brief side, and is carrying nothing that can come off him. Behind him, a loader is squaring up on the ramp. A fuel crew has already bonded a hose, and a crew chief has counted the people inside that area twice. In front of him, the aircraft has not stopped for a second, and it will be gone in a few minutes with a different load and full tanks. That is what saved time actually looks like. Not people rushing, but a set of moves decided so completely in advance that they can be carried out beside something nobody turned off. The minutes are real, and they are the whole reason any of it exists. They were bought by removing almost every choice from the people doing the work, deliberately and long before the aircraft landed. All of this assumed one aircraft on the ground was somewhere to be. But there is a version where it is not one aircraft, And the thing under pressure is not a turnaround. It is the whole airfield. Everything the wing owns, launched one after another with minimum spacing until the ramp behind them is empty concrete. Next time, how a wing puts all of it into the air at once, and what the rules are when an entire base leaves.